In this presentation, the most frequently occurring natural disaster types, namely earthquakes, storms, floods, and wildfires, are addressed. The presentation aims to provide a framework that supports ecological planning and design approaches developed within the scope of EPD-Net for disaster-resilient and sustainable cities. Natural disasters are not considered solely as nature-based events, rather, they are addressed as multidimensional risks with social, spatial, economic, and environmental dimensions. It is widely acknowledged that a significant proportion of the loss of life and property resulting from disasters is caused not by the disasters themselves, but by insufficient preparedness and lack of preventive measures. For this reason, understanding disasters is not limited to their definition, but also includes the evaluation of how their impacts can be reduced. Throughout the presentation, the fundamental characteristics, impacts, and protection measures related to different disaster types are examined. In addition, the intensifying effect of climate change on the frequency and severity of disasters is discussed. Within this context, the importance of enhancing resilience at the levels of individuals, communities, and cities is emphasized. This slide outlines the overall structure of the presentation and summarizes the content flow to be followed. The presentation is designed to progress within a systematic framework. First, the learning objectives are presented, followed by an overview of the most frequently occurring natural disaster types. This section aims to support an understanding of why disasters are considered a significant risk factor. In the subsequent sections, earthquakes, storms, floods, and wildfires are addressed in detail under separate headings. Within this scope, the definitions, causes, fundamental characteristics, and impacts of each disaster type are explained. In addition, protection and preparedness measures are presented in order to emphasize risk reduction approaches at both individual and societal levels. In the final part of the presentation, the impact of climate change on natural disasters is examined, and the reasons behind the increasing frequency and severity of disasters are explained. Within this framework, the importance of resilient and sustainable cities is emphasized, and the presentation is concluded with a summary and key takeaways. This slide presents the main learning objectives of the presentation. The first objective is to establish a conceptual framework regarding frequently occurring natural disaster types such as earthquakes, storms, floods, and wildfires. Within this context, an understanding of how disasters occur and under which conditions they pose risks is intended to be developed. The second objective is to explain the impacts of natural disasters on human life, settlements, and the environment. It is emphasized that disasters do not only result in physical destruction, but also lead to social, economic, and environmental consequences. Through this approach, the multidimensional nature of disasters is intended to be better understood. The third learning objective is to draw attention to protection and preparedness measures that can be taken against disasters. The importance of risk reduction strategies that can be implemented at individual, societal, and urban scales is highlighted. In this context, the necessity of developing disaster-resilient and sustainable settlements is emphasized. This slide addresses the most frequently occurring natural disaster types worldwide within a general framework. Earthquakes, storms, floods, and wildfires are considered disasters that, despite occurring in different geographies and arising from different causes, can result in similar levels of loss of life and property. The frequency and impact of these disasters are directly associated with both natural processes and human activities. A common characteristic of these disaster types is the significant pressure they exert on settlements and infrastructure systems. Unplanned urbanization, environmental degradation, and inadequate risk management are identified as factors that further increase the impacts of disasters. For this reason, disasters are addressed not only as sudden events, but also as processes that require long-term planning and management. Within this context, recognizing frequently occurring disaster types and understanding their fundamental characteristics are considered critical steps in the development of effective disaster risk reduction strategies. This slide addresses the concept of earthquakes and the main types of earthquakes. An earthquake is defined as the shaking of the Earth's surface that occurs as a result of the sudden release of accumulated energy within the Earth's crust. This release of energy generally takes place along fault lines due to tectonic movements. Because of their sudden and unpredictable nature, earthquakes are considered among the most destructive natural disasters. Earthquakes are classified into different types based on their causes. The most common type is tectonic earthquakes, which occur as a result of plate movements and account for the vast majority of earthquakes worldwide. Volcanic earthquakes occur in connection with volcanic activity and are caused by the movement of magma beneath the Earth's surface, typically in regions close to active volcanoes. Subsidence earthquakes result from the collapse of underground cavities and usually affect relatively limited areas. This classification contributes to a better understanding of the causes and potential impacts of earthquakes and serves as a fundamental reference in earthquake risk assessment studies. One of the primary protective actions recommended during an earthquake is the drop, cover, and hold on method. This method aims to reduce the risk of injuries caused by falling or overturning objects during ground shaking. During its application, individuals are advised to drop to the ground, take cover under a sturdy piece of furniture in order to protect the head and neck, and hold on until the shaking stops. However, it is particularly emphasized that this method is effective only in structurally sound and safe buildings. In buildings with weak structural systems, existing damage, or those that have not been designed according to engineering standards, this behavior may not provide an adequate level of protection. This situation indicates that individual protective actions alone have limited effectiveness in the absence of structural safety. For this reason, conducting the necessary technical assessments and performance analyses to determine the earthquake resistance of buildings is of great importance. Ensuring structural safety is considered a fundamental factor that directly increases the effectiveness of individual protective measures applied during an earthquake. After an earthquake, it is widely acknowledged that access to assistance and emergency services may be limited, particularly during the first 72 hours. For this reason, preparing an earthquake emergency kit that can meet basic needs is considered essential for individuals and families. An earthquake kit is regarded as a preventive preparedness tool that facilitates survival and supports basic needs in the aftermath of a disaster. The essential items that should be included in an earthquake emergency kit consist of an adequate supply of drinking water, non-perishable food, a first aid kit, blankets, a flashlight, spare batteries, a whistle, a radio, hygiene products, and copies of important documents. It is emphasized that these materials should be checked regularly and updated when necessary. It is particularly noted that earthquake emergency kits should not be limited to a standard set of items, but should instead be customized according to the specific structure and needs of each family. In cases where there are individuals requiring special care, such as people with disabilities, elderly individuals, children, or infants, necessary medications, medical supplies, special food items, or assistive equipment should be included in the kit. This approach highlights the importance of planning disaster preparedness processes by taking individual differences and special needs into consideration. A storm is defined as a meteorological event that is generally characterized by strong winds and can cause adverse effects on living beings and the environment. Storms are often accompanied by other weather phenomena such as heavy rainfall, lightning, hail, or snow. This combination can increase the intensity of storms, leading to damage to buildings, disruption of infrastructure systems, and interruptions in daily life. The formation of storms is associated with atmospheric pressure differences and temperature variations between air masses. It is widely acknowledged that, due to climate change, both the frequency and intensity of storms have increased. For this reason, storms are considered a significant natural hazard within the scope of disaster risk management. Storm hazard maps are considered important tools used to identify areas that are highly exposed to strong winds and extreme weather events. These maps are produced using historical storm data, meteorological observations, and climate models. In this way, information is provided regarding the frequency and potential intensity of storms in specific regions. The use of storm hazard maps contributes to the early assessment of disaster risks and the planning of preventive measures. They are regarded as valuable references, particularly in terms of settlement planning, infrastructure design, and the development of early warning systems. In the process of protection against storms, it is acknowledged that individual and environmental measures should be addressed together. First, regular monitoring of meteorological warnings and weather forecasts is considered essential. During a storm, remaining in strong and enclosed spaces, and ensuring that windows and doors are securely closed are recommended. It is emphasized that outdoor items located on balconies or in gardens should be brought indoors, electrical devices should be unplugged, and trees and power lines should be avoided. Parking vehicles in covered areas and staying away from the sea and open spaces are also regarded as basic safety measures. These precautions aim to reduce the risks of injury and damage caused by storms. A flood is defined as a natural disaster that occurs when water temporarily or permanently inundates areas where it is not normally present, such as residential zones, agricultural lands, or natural environments. Floods generally result from excessive rainfall, snowmelt, sea level rise associated with storms, tsunamis following earthquakes, or dam failures. These events may cause water to spread rapidly and uncontrollably, leading to significant loss of life and property. The severity of flood impacts is directly associated with regional topography, infrastructure capacity, and land use patterns. For this reason, floods are regarded as an important hazard type within the scope of disaster risk management. In areas with a high risk of flooding, the use of physical flood barriers is regarded as an important protective measure aimed at controlling water flow. Flood barriers are defined as temporary or permanent structures designed to limit the entry of water into residential areas, buildings, and critical infrastructure. Through the use of these barriers, the spread of floodwater can be slowed and the extent of material damage can be significantly reduced. It is emphasized that, particularly in flood-prone areas, the use of barriers should be planned in advance and implemented at appropriate locations. When combined with early warning systems and other preparedness measures, flood barriers are acknowledged to contribute significantly to the reduction of the adverse impacts of flooding. It is widely acknowledged that measures taken before the occurrence of a flood play a decisive role in reducing flood risk. In this context, individuals living in flood-prone areas are expected to follow up-to-date warnings and official information. Potential evacuation routes and safe assembly areas should be identified in advance. In addition, preparing emergency kits and storing important belongings in locations that are not likely to be affected by rising water levels are recommended. In areas with a high risk of flooding, leaving the area before flooding begins is emphasized as an effective measure for reducing loss of life. These precautions aim to ensure preparedness against the possible impacts of floods. During a flood, ensuring personal safety is considered a top priority. In this process, it is recommended that electricity and gas connections be disconnected whenever possible. It is emphasized that the presence of floodwater inside buildings may increase the risks of electric shock and fire. It is particularly stated that walking or driving through flooded areas should be avoided. Since the depth and flow speed of floodwater are unpredictable, such actions may lead to serious injuries or loss of life. For this reason, moving toward higher and safer areas and promptly following evacuation instructions issued by authorities are considered essential. After a flood, it is acknowledged that risks do not completely disappear and that caution must continue to be exercised. Considering that floodwater may contain contaminants and harmful substances, direct contact with such water is strongly discouraged. In addition, approaching damaged power lines and compromised infrastructure elements is considered hazardous and should be avoided. It is particularly emphasized that homes or disaster-affected areas should not be re-entered until they are officially declared safe by the relevant authorities. Once safe return is permitted, cleaning and disinfecting living spaces are recommended. Furthermore, informing family members about one's safety by maintaining communication is considered an important step in effectively managing the post-disaster process. Wildfires are defined as disasters that spread uncontrollably across forested areas as a result of natural or human-induced factors and cause severe damage to ecosystems. These fires lead to the destruction of vegetation, harm to wildlife, and deterioration of air quality. In recent years, a noticeable increase in both the frequency and intensity of wildfires has been widely acknowledged. This increase is directly associated with climate change-related factors, such as rising temperatures, prolonged droughts, and decreasing humidity levels. For this reason, wildfires are regarded as one of the disaster types that clearly demonstrate the impacts of climate change. It is widely acknowledged that the environmental, economic, and social impacts of wildfires have become increasingly visible in recent years. These impacts are not limited to the areas where fires occur, but also lead to long-term consequences for ecosystems, air quality, and human health. The destruction of vegetation, loss of biodiversity, and decline in soil fertility are among the primary environmental effects of wildfires. This situation has been clearly observed through recent large-scale wildfire events. In Australia, extensive wildfires have damaged millions of hectares of land and resulted in the loss of a significant number of wildlife species. In Turkey, the Manavgat and Marmaris wildfires threatened residential areas and caused substantial economic losses. These examples demonstrate that wildfires represent not only a natural hazard, but also a serious societal risk. Climate change is not classified as a disaster in itself, however, it is regarded as a fundamental risk-enhancing factor that transforms the conditions under which disasters occur and amplifies their impacts. Increases in global temperatures are acknowledged to cause changes in atmospheric circulation systems, leading to significant effects on precipitation regimes, wind intensity, and seasonal patterns. As a result of these changes, certain types of disasters are observed to occur more frequently and to produce more destructive consequences. With particular regard to wildfires, rising temperatures and prolonged drought periods are reported to make vegetation more susceptible to ignition. Reduced humidity levels and intensified wind conditions contribute to the rapid spread of fires and hinder effective control efforts. This situation demonstrates that wildfires do not only result in ecosystem loss, but also generate cascading effects on air quality, carbon emissions, and public health. In the case of floods, the increasing occurrence of intense rainfall over short periods is considered a major factor that elevates the risk of sudden flooding events. When the water absorption capacity of soils is exceeded, and when urban drainage systems prove insufficient, especially in areas affected by uncontrolled development along riverbeds, the severity of flood impacts is significantly increased. In addition, sea level rise and storm-induced surges are identified as contributing factors that intensify coastal flooding. Regarding storms, it is widely accepted that a warmer atmosphere can retain more water vapor and energy, thereby increasing the likelihood of extreme wind events accompanied by heavy precipitation. In this context, climate change is addressed not only as a factor that raises the probability of disasters, but also as one that magnifies their overall impact and scale. Consequently, it is emphasized that disaster risk reduction strategies should not be limited to emergency response alone, but should be supported by long-term adaptation policies aimed at strengthening urban and community resilience. When all disaster types discussed in this presentation and their relationship with climate change are considered, it is widely acknowledged that disasters cannot be completely prevented. However, their impacts can be significantly reduced. At this point, the concept of resilience emerges as a central approach within disaster risk management. Resilience encompasses not only the capacity to recover after a disaster, but also the ability to reduce risks and adapt before disasters occur. The first and most critical component of resilience is the development of safer buildings. It is recognized that a large proportion of disaster-related fatalities result from inadequate structural design and poor construction quality. For this reason, designing buildings in accordance with disaster risks, conducting regular inspections, and implementing necessary retrofitting measures are considered fundamental elements of risk reduction. Secondly, informed and aware communities are emphasized as being more resilient to disasters. Disaster awareness, knowledge of appropriate response behaviors, and higher levels of individual preparedness play a crucial role in minimizing loss of life. Through education, training, and preparedness activities, communities are enabled to respond more effectively to disasters. Finally, the development of sustainable cities is regarded as a key factor in achieving long-term resilience. Planning approaches that integrate natural risk considerations, green infrastructure systems, and climate-adaptive urban policies are acknowledged to contribute significantly to disaster risk reduction. In this context, it is concluded that safer buildings, informed communities, and sustainable cities must be addressed together, and that resilience requires a comprehensive and integrated approach. The information presented in this presentation is based on internationally recognized academic studies and institutional reports related to disaster risk reduction, climate change, and resilience. Publications issued by organizations such as the World Health Organization, the United Nations Office for Disaster Risk Reduction, and the Intergovernmental Panel on Climate Change constitute the scientific foundation of the presentation. In conclusion, it is emphasized that effective action against disasters should be carried out on the basis of scientific knowledge, planning, and societal awareness. This approach is widely regarded as essential for building a safer and more resilient future.